This kind of question is so common, and as teachers love putting them in there in your tests and exams because it tests so much of your knowledge, your reduction formula, your special angles, your compound angles. So it's really one that you want to make sure you are very comfortable with. Okay. All right, so let's have a look at what they're saying. If sine of alpha is equal to a ratio of 4/5, where alpha is less than 90 degrees and cos beta is equal to negative 12/13, where beta is between 0 and 180 degrees, evaluate the angle of, or the expression of cos beta minus alpha. Okay, now this is straight away one of your Pythagoras type questions, okay? As soon as you see this, as soon as you've been given a trig ratio and you've been given the size of the angle or kind of a restriction of where the angle belongs, you most definitely want to do yourself a diagram, okay? And by a diagram, I mean you want to give yourself a Cartesian plane, all right? Now, first of all, sine, do you agree, is a positive ratio? Sine alpha is equal to 4/5. Now, on your Cartesian plane, which two quadrants was sine positive in? It was positive in your first and your second quadrant, okay? But we're being told here that alpha is less than 90 degrees. So if it's less than 90 degrees, it means it actually has to be in quadrant 1. So the diagram that applies to this first angle of alpha is definitely going to be in your quadrant 1. So we're going to draw ourselves a little diagram into quadrant 1. You can see I've got my little right angle triangle there. And we've got the angle of alpha in standard form. Now remember, sine is the ratio of your opposite side over your hypotenuse side. So 4 is my opposite side, 5 is my hypotenuse side, and by using Pythagoras, remember Pythagoras, which is your x squared plus y squared equals r squared, okay, you remember that? You're going to find your missing side being 3, okay? All right, so we've got this little diagram for the first part of it, okay? Now let's have a look at what the second one was saying, all right? We've got a ratio of cos beta, which is now negative 12/13, and angle beta is between 0 and 180. So again, let's give ourselves our little our x and our y axes, and let's determine which quadrants we're going to be working in here, all right? If cos is a negative ratio, all right, well, cos was negative in my second and my third quadrants. That's where cos is negative, all right? But it says that we are only working from 0 to 180 degrees, and 0 to 180 degrees is taking up quadrant 1 and quadrant 2. So do you see that it's in quadrant 2 where all the conditions are satisfied? So it means your diagram is going to be drawn into quadrant 2. Okay, so let's draw our triangle into second quadrant. Okay. And we're going to put angle beta in standard form, in standard position. All right, cos is the ratio of your adjacent over your hypotenuse. So this time your adjacent side is negative 12, your hypotenuse is 13. Again, Pythagoras is what you need to apply to find your missing side over here, which is going to be 5. Okay, all right, now that you've got those two little diagrams in place, now we're going to have a look at this. Do you see that that is most definitely a compound angle? Okay, so we're going to have to stretch it out, all right? So by stretching it out, let's see, we've got cos b, beta, cos alpha, c for cos, c for change the sign, and then I've got sine beta, sine alpha. Okay, and now we need to do the following. I've got cos of angle beta. Now, if this is angle beta over here, cos from beta is my adjacent over my hypotenuse, which is negative 12/13. So I can replace cos of beta with the ratio of negative 12/13, all right? Cos of alpha is going to be coming from this triangle, all right? Cos is the ratio of your adjacent over the hypotenuse. That's going to be 3 over 5. All right, so 3 over 5 is what we can replace that with. All right. Sine of beta, so back to my beta. Sine is my opposite over hypotenuse, so that's going to be 5 over 13. And sine of alpha, sine is my opposite over hypotenuse, so we've got 4 over 5. Okay, so by using those diagrams and by stretching out using the compound angle, I've managed to now actually give myself quite a nice sum to work out. Just timesing your terms together, we're going to land up with negative 36 over, this is going to land up being 65 plus 20 over 65, and that is going to simplify to negative 16 over 65. And there we go. We've evaluated it. We've given it a value, all right? And we did that by using these Pythagoras type questions, okay? So like I say, the second you have got a ratio and you've been given sort of a restriction as to where the angle belongs, you need to do these. You need to decide on which quadrants you are in. Do your right angle triangle, use Pythagoras to find your missing sides, and then from there, it's a case of reading off the diagrams. Okay, please practice those. The Pythagoras type questions are always there in your tests and your exams, and they're definitely worth the marks. Okay, good job. We'll see you next time.